everyone, I am Mark Hochman with PC World, and we are here with Michelle Johnston Holthouse, the general manager of Intel's Client Computing Division here at Intel Innovation. Hello.
Hi, thanks for having me.
And we are here to talk about Meteor Lake, which Intel just introduced. This is Intel's 14th generation core processor. It's specifically a mobile part. Would you mind just hitting the high points of what we need to know about Meteor Lake and how it differs from its predecessors?
Yeah, so we're branding Intel Core Ultra, and it is a very balanced and holistic CPU is the way that I like to think about it. So think about Raptor Lake-like performance, discrete level GPU, so we brought our Intel Arc graphics down, so 2x the graphics performance, about half the battery, so performance per watt about half in comparison to what you would have seen on Raptor Lake, and our first ever integrated NPU, so AI capabilities within the silicon stack.
So one of the things that's important to me was the fact that you guys are really emphasizing low power on this. So from a performance standpoint, I think talked a little bit before, you're talking about the performance of the prior generation 13th gen core, but with is half the power, that's right? Okay, great. And we're doing that in a couple of different ways. I mean, you have the Intel 4 process technology where you're disaggregating the different tiles, but you're also doing some interesting things with low power E-cores and Thread Director too. And I wanted to ask you a little bit about that. So can you explain what a low power E-core is and how it differs from, say, a P-core or a regular E-core?
Yeah, the way I look at it is we have this low power SoC island, and the way you should think about that is these are low power SoCs that run in the background and can continually run things at a much lower power state. And so this is the architecture that we've implemented with Meteor Lake and on, which really allows us to achieve that about 50% metric that we talked about. And we really did that because what we heard from customers is we needed better performance per watt. They did not want to get up that performance threshold, but they wanted better battery life. And we know that that is something that both commercial and consumers are looking for. And so we were able to implement it in this new way, which I'm very, very excited about. And you mentioned Intel Thread Director, Mark. This is important because it actually tells the workloads where they should go. So if it's a burst capability, obviously you'd want it on the core performance CPU. But if it's something that's just running in the background, then you're going to want it on that low power SoC island.
And one of the things they showed off actually running on those low power cores was, video decoding. I mean, you're actually playing back video, which is a really interesting thing for a laptop, like on a plane, for example, because you're not touching any of the core except for that little bitty E-core. That's going to allow your battery life to go a lot longer, I imagine.
Exactly.
Okay, great. The other thing, though, I wanted to ask you about was just the policy change you guys are making with Thread Director. So in previous core chips, if you had a new task, a new thread, you would push it to the P-core first. And that would just, again, sort of emphasize performance. But here, you're starting off with the very lowest E-core, if it's all possible. Why is that?
Because to get a balanced platform and to deliver that better battery performance, you got to start at E-core and then bounce up. If you start at P-core, you're automatically consuming that energy and then moving down. And so part of it is just a fundamental shift of saying, hey, we need more and more to be able to run on those E-cores. And we need to use P-cores when it's most important. And so it's about that balanced platform. But we just continue to hear from customers of, I want a balanced platform, I want better battery life, however, I don't want to sacrifice performance. So by being able to put it on the E-core and knowing that you need to move it to the P-core, the user can still have a great performance experience. It just doesn't use the same, it doesn't expend the same battery that it would have before.
But this is a policy change, though, right? So you could, if you wanted to have, say, a gaming optimized processor, could you go ahead and change that and say, okay, we're going to push tasks to the P-cores first?
Well, you could write that into Intel Thread Director if we choose to do that.
If you choose to,
yes, absolutely.
Okay.
I mean, Intel Thread Director is a living being, is the way I think about it, and so that is going to evolve to deliver the best performance for the machine, for the silicon that we have at the time that we have it. So we'll listen to our customers. If there are certain workloads or experiences that need to land on the P-core first, then that's something we would certainly consider.
Yeah, and you're right. I mean, you have to serve both worlds. You have to serve sort of the business people who like to have that all-day battery life, and then you have to have like the gamers who just want performance up the wazoo. And that's kind of where I wanted to ask you next question too, is that you guys are stepping through 5 process nodes in 4 years. I mean, you guys have made a big step, big deal about that. This is Intel 4, Intel 3, and then you got 18A. There's a lot of, first of all, and historically, I guess there's a school of thought that says you don't want to launch a new chip on a new process because it introduces too many variables, there's too many possibilities for things to go wrong. Is this mindset just out of date at this point in time, or is there something else going on?
Well, the way I look at it, especially with disaggregated architecture, is I want to deliver the right chip on the right node.
Okay.
So the way I think about it is, what node does that chip need?
Sure.
So sometimes, actually, like if you think about our communication, they actually need older nodes. If you think about the core,
Right.
wants the most performant node.
Okay.
And so I think with Meteor Lake, we've proven that you can deliver a new core and a new node on time and have it be performant and have happy customers. So we're going to continue to look at it that way. So from here forward with disaggregated architecture, I'm literally with my team
Sure.
looking at every core, every chiplet, and where's the best place to land it and on which process.
Let's talk about that in just a
Yeah.
second. I have one more question for you in
Please.
that regard. So if you are stepping through 5 process nodes in 4 years, does that mean we're going to see a lot of ticks? We're going to see a lot of emphasis on low power, going through there, not so many talks? I mean, is that right?
No, there's talks that
Okay.
come along with it as well. I mean,
Okay.
I kind of use, if I look at the roadmap that we have coming, we have both ticks and talks in that roadmap.
Okay.
And again, I think it's the node for the architecture, right? So when you think about Meteor Lake being on Intel 4, that's the right match. Arrow Lake will be next generation node. So we're just continually looking at saying, hey, what is the right node for the right process? And we have 5 nodes in 4 years, which is definitely a sprint. But we're really choosing which one makes the most sense for our customers. At the end of the day, we want to deliver what the consumer needs.
Now, Meteor Lake right so far is just a mobile chip, and you guys haven't said anything about desktop. Let me ask you, I mean, is there going to be a Meteor Lake desktop, or you guys
Desktop will
aren't saying
come in 2024.
So desktop, so you are confirming Meteor Lake desktop?
Yes.
Okay, great. So that was going to be my next question, was whether or not you guys were sort of returning to an era where there was going to be a processor family for mobile and a separate processor family for desktop, but it doesn't sound like that's the case.
That is not the case. I want one processor family top to bottom
So
for
do we.
both segments. Doesn't everybody?
Right, exactly.
It's a lot easier said than done.
Quick question, so let's talk a little bit about the tiles. You have 4 tiles now. You have CPU, graphics, I/O, and SoC.
Correct.
And the SoC, of course, is when those low power cores live on. My question is, okay, so you're going to bring this thing to market. It comes to market in December.
December 14th.
December 14th, great. How is that going to be? How are you going to tell users what they're getting? I mean, we've had model numbers in the past. Are we going to see a revamp of that with different to indicate which tiles people are going to get?
No, I think when we think about Meteor Lake, we're going to talk about experiences.
Okay.
So the way that I've been talking with our customers about it, who bring these products to market, is we need to talk about personas. So
right.
for example, you're a commercial customer and AI and low power may apply to you in a different way. And so we need to market and communicate it in that way. So for example, how does CrowdStrike work better on a machine like this?
Right.
What security capabilities, might you have? What IT infrastructure or local applications could be run more securely in a commercial like PC? Hey, if you're a consumer, and let's just say you're a photographer,
right.
Hey, how is Adobe going to run differently? So I look at this as more of, we've got to start talking about the usage models that people are going to get out of this, because I think particularly with the neural processing unit or the NPU, there's so many things that we don't even know today. And I don't want to define and say this is what it is.
Sure.
I want to release these billions of tops and unleash this amazing developer ecosystem to write, innovate, and create in ways that they never thought possible. And they're going to teach us actually what the silicon can do.
Okay. One more question in this
Please.
regard. So 4 tiles, 4 different roadmaps. Are we going to see these 4 different iterations? We're going to have things overlap with one another, or are we going to see like a new processor mean 4 new tiles, or 5 new tiles, or 8 new tiles?
Oh no, so we'll take up, I guess the easiest way to answer that is there will be architecture pieces of each node that move forward to the
Okay.
next node.
Right.
But let's just continue to talk about the NPU. All the work that's done in the NPU on Meteor Lake ports forward to the NPU that you'll see with Lunar Lake, even though it's larger and more performant. But the work from a software and hardware integration perspective ports forward. So I think that it's more important to think about the way the technology moves from the node versus how the chiplet moves from the node.
Okay. Now we're talking about AI. How are you selling that to consumers? I mean, it's kind of a challenge. I mean, you're talking about experience and so forth. What sort of experiences are you going to tell consumers that improve with an AI?
Yeah, it's a very, very good question.
Yeah.
And I think, to be honest with you, that script's kind of being written real time.
Sure.
Because the world is inventing what's going to show up on AI. But we know things like collaboration, we know personal assistant, we know security, we know all of those are key elements that consumers are interested in.
Sure.
If you're a creator or a gamer, we already know that AI adds a lot of functionality and capabilities. So, you're in Lightroom and you're editing a picture.
Exactly.
I mean, if you can speed that up, that's fantastic. If you're a creator and you could be creating graphics in new ways, that also helps. But I also think we have to spend some time listening to those consumers and saying, hey, what are the issues and the problems and the challenges that I have in my daily life, and how can we apply AI to that? That's why I keep saying, I don't want to define what success looks like. I want to unleash the marketplace to help us define how is AI going to be successful, what problems is it going to solve, and why are people so excited about it?
And it's not just the NPU. I mean, you can go ahead.
No, it could be the NPU, the GPU, or the CPU. I think that's what's so amazing about AI. And that's also where I think Intel really shines. When you think about the way that Intel Thread Director works, think about OpenVINO in the same way, where you can start to direct workloads to the right performant silicon architecture, and you can take advantage of a very balanced platform because we have all three, and they're all performant, and that really allows the software developer to really think about how to best optimize their software for our silicon.
That makes sense. That makes sense. Okay, great. So we also have a more technical, detailed examination of what Meteor Lake is, both on the video side of things on our YouTube channel, as well as on PC World's site itself. So, Michelle, thank you for being with us.
Thank you for having me.
Thank you for watching. Go ahead and keep it tuned to PC World's YouTube channel for more.